All right, part 3. And yay, no more graphs here. Here we're going to determine the domain when we just are given the equation. So the first thing we have to know is if the domain of a function, if it's not specifically told to us, then it's implied. Right? Implied means something that we aren't specifically told, but we're supposed to understand. And we're supposed to understand that it's the biggest possible set we could have where we still get real numbers as our output. No imaginary numbers, just real numbers. And there's really only 3 special cases, and you should put like a little box or a little star beside this. This is the only 3 cases where we have to remember. If it looks like a fraction, the bottom can't be 0. If it looks like a square root, then the a has to be bigger or equal to 0. Could be 0, but it cannot be negative. And if it's a log, we can't have 0 or a negative. So those are our only 3 cases. And we're not even going to have any of these log ones right now. We'll talk about logs a whole bunch later on. But for now, these are our only 2 cases. Can't be 0 on bottom, and in a square root, it can't be negative. So when we look at these, this first one, does it look like either one of these 2? Nope. So that means that the domain is all real numbers. If it's not one of our 2 examples, then it's all real numbers. Then to find my x and y intercepts, when I find my x intercepts, if I think about a graph, the x-intercepts is where it crosses the x-axis, and it crosses the x-axis where y equals 0. So the x-intercept is always where y equals 0. And my y-intercept is where it crosses the y-axis. And where it crosses the y-axis, then my x is always 0 here. So to find each one of these here, I'm going to plug in y equals 0, and here I'm going to plug in x equals 0. So this is a quadratic. For quadratics, I'm going to plug in y equals 0 here, and I get 0 equals 5x squared plus 4x minus 1. And we remember back from Algebra 1 to however you go about factoring this, whether you use the box method or another method. On one that's pretty easy like this, we can just go straight to factoring it, because there's only one way to get 5x. It's got to be 5x and x. And there's only one way to get 1, which has to be 1 and 1. And then I just have to put in the negative signs in the right place. I want the 4 to be positive, so I need this one to be negative and this one to be positive. I can double check that with FOIL. Remember your little FOIL. Use your FOIL to double check that we got it right. Then our next step is we set each one of these equal to 0. So I have 0 equals 5x minus 1, and I have 0 equals x plus 1. Solve this, add 1 to the other side. 1 equals 5x, divide by 5, and we get x equals 1/5. Then I do the same thing with here, minus the 1 to the other side, and I get x equals -1. So there's my 2 x-intercepts. To get my y-intercept, this one is even easier. I just take and plug in a 0 for the x every time it over here. So I get y equals 5 times 0 is 0. 4 times 0 is 0. Minus 1. So I just get y is -1. Sorry about that. You can see my dogs were very excited that y equals -1. Alright, so that was it for our problem. Okay, so our next one. Does this one look like one of our examples up here? Yes, this looks like a fraction, so all we do to solve it is we just use this part right here, where the bottom is not equal to 0. That's all you do. You just take the bottom, this is the bottom, and we say that not equal to 0. X minus 5 not equal to 0. And then I solve this just like normal. I add 5 on both sides, and I get x not equal to 5. That's the whole thing. There's a little hole at x is 5, and that's our whole domain. Done. Then I'm going to use these same 2 things we did before to find the y-intercept. To find the x-intercept, I'm going to put in y equals 0. And this is pretty easy on this kind, so I'm putting in y is 0, 3x over x minus 5. And then to get rid of something on bottom, I just multiply times the thing on bottom. But what's nice about this is this cancels on this side, and what's 0 times anything? 0 times anything is just 0. So really, if I've got a fraction, I'm just putting the top is all that needs to be 0. So we get 0 is 3x, divide by 3, x equals 0. Then to get my y-intercept, I plug in 0 for all the x's. Alright, so 0 is going to go in for each of these. Y equals 3 times 0, that's 0, over 0 minus 5. Well, it doesn't even matter what's on bottom, because if there's a 0 on top, it's just equal to 0. Alright, and then my last one here. Does this look like one of ours up here? Sure does. It's a type 2. It's a square root. And all I have to remember is the thing inside can't be negative. So it's got to be greater or equal to 0. So I literally take the thing inside, and I write it down, and I write down greater than or equal to 0. Then I solve it. Minus 4 on both sides. X is greater than or equal to negative 4. And done. The only thing I have to remember when I'm doing these is if you ever multiply or divide by a negative, you have to flip the sign. So just don't forget that from our little Algebra 1 rule that we had before. Alright, now we're going to do the x and y intercepts the same way we did before. I'm going to plug in 0 for y for this first one. So here I'm going to plug in 0 for y. 0 equals square root of x plus 4. How do I get rid of a square root? By squaring. So I get 0 squared is still 0, x plus 4. And subtract the 4, I get x equals negative 4. And for the y-intercept, I'm going to plug in x equals 0. So here I'm going to put in y equals square root of 0 plus 4. 0 plus 4 is still 4. Square root of 4 is 2. And done. Alright, then on our back of our page, using function notation. This is just a little reminder back again from Algebra 1, a little review. Anytime I put the number in here, I'm going to plug it in for the x's. So here I'm going to plug it in and I get negative 3 squared minus 3 times 2 times negative 3. So 2. Well, what I have to remember is negative 3 squared. If you try to do it on your calculator and you aren't careful with putting in the parentheses, you're going to get it wrong. So we want to make sure that this is a positive. Negative 3 times negative 3 is positive 9. And then negative 2 times negative 3 is positive 6. So we get 15. Now these two, notice the difference in these two. Here it says to put the negative out front, and here it says to put in a negative x. So this one it wants me to put the negative out in front, like this. This one is different. It wants me to put the negative in every time I see the x. So here I'm going to put in negative x squared minus 2 times negative x. Notice these two are not the same thing. Here I'm going to distribute this negative like this, and I'm going to get negative x squared, and then that one's going to be a positive 2x. Here, this one's positive, because a negative times a negative is a positive, and then this makes a positive here. So notice those didn't come out the same. And then this one wants me to put in x minus 3 every time I see an x up here. So it's going to be x minus 3 squared, and then minus 2 x minus 3. This one, remember you cannot distribute this one. This one you have to write it out 2 times and FOIL. So I need to write it out like this, x minus 3 and x minus 3. And so I get x times x is x squared, x times negative 3, my outsides, that's negative 3x. Then my insides, negative 3x. And then my last ones is positive 9. And then this one I am going to distribute. I don't distribute the exponent. I do distribute the number in front. And you do need to remember that it's this whole negative 2 that I'm distributing. So negative 2 times x is negative 2x. Negative 2 times negative 3 is positive 6. Now I just need to combine like terms. So I have x squared. Then here's my like terms. These two and this one all match up. So that gives me negative 8x. And then this one and this one give me 15. And then this says, is this equal to this? Well, the way to figure out is to work out both of those sides. I've actually already done this piece, was right here. This is the same as this one. So we know this first part equals this part. X squared, I'm just going to copy it over. And I'm going to decide, is this the same as this part? Well, this was just my original equation. So this part is x squared minus 2x, my original problem. And then I've already done this part also. That was the first part we did, which we found was just 15. So are these two things equal? No, they're not the same because it's got an 8 and this has got a 2, so these things are not equal. So these two things are also not equal. All right, and now just another different little problem. Here's our new f of x. And first it says, what's the domain? Well, let's look back at our types of problems. Is this one of our kinds? Yes, it is. It's a fraction. So we remember that the bottom cannot equal 0. So I literally, once again, take the bottom part, and I just do x plus 2 not equal to 0, minus a 2, and I get x not equal to negative 2. That's my domain. Then it says, what is f at negative 1? So I'm just going to plug in negative 1 for my x's. So I have negative 1 plus negative 3 on top. And on bottom, negative 1 plus 2. So on top I have negative 4, and on bottom I have 1. So that just gives me negative 4. And what point is on the graph of f? So it wants me to just write it out as a point on the graph. Well, this is my x, negative 1 is my x, and negative 4 is my y. And so it's as a point. Where does f at 2 happen? So this is y. So it wants me to just plug in y for here, 2 for y, and then solve. 2 equals x minus 3 over x plus 2. So I'm plugging in 2 for y. Now to solve this, we already said just multiply the bottom times itself. Take the bottom times itself, that cancels that part out, and it moves it over here. And this is not an exponent, this is a regular number, so I'm going to distribute that. So I'm going to get 2x plus 4 equals x minus 3. Now this is just a little algebra problem for us to solve, so we're going to minus the x. And so this gives me x. This gives me x plus 4 equals negative 3, minus the 4 on both sides, and I get x equals negative 7. So I got negative 7, and then once again they just want me to remember that this is really a whole point. So here, x is negative 7 and y was 2. Then it says, is this point on the graph? Well, we're doing all this without graphing, so it just wants to know, is this point on the graph? I can just plug this in for x and this in for y and see if it works out. So here's my equation again. So I'm going to plug this in for y, negative 1/2 equals, and then I'm going to plug in 1 for my x's. 1 minus 3 over 1 plus 2. So I just plugged in my x's there. On top I get 1 minus 3 is negative 2, and on bottom I get 3 is 1/2. Negative 1/2 equal to negative 2/3? Nope. So that's a no. And where does it cross each axis, the x and y axis? So we're going to find where it crosses the y equals 0. This is where it crosses the x-axis. And at x equals 0 is where it crosses the y-axis. So for this one, I'm going to set the whole thing equal to 0. Remember, when I multiply times the bottom, it really just goes away because this side cancels and anything times 0 is still 0. So this side, add 3 to the other side, I get at x equals 3. That's my x-intercept. And then my y-intercept, I'm going to plug in x equals 0. So I'm going to plug in zeros for my x's. So I have 0 minus 3 over 0 plus 2. So this gives me negative 3/2 equals y. That is my y-intercept.